Okay, so today, finally, concurrency. And we're gonna spend maybe 2 or 3 lectures on concurrency, and then we gotta go over 2 major topics. First one is something called Grand Central Dispatch. Okay, and these two are different concurrency model, and right now they are coexist in the Swift ecosystem. Okay, so you can choose which one to use, whatever suit you purpose best. Okay, and first is something called Grand Central Dispatch, and the second one is called Swift concurrency. Okay, this is kind of official name by Apple. It's called Swift concurrency. Well, essentially just some async await syntax come with Swift. And since all these things come with the language feature, integrated as some kind of language feature, so Swift called that as Swift concurrency. Okay, so today we're gonna focus on the Grand Central Dispatch, and maybe next time we're gonna go over the Swift concurrency. Okay, so Grand Central Dispatch. Again, there's some definition from Apple's official documentation. And you can just read all these things, quite boring. But I also have the URL here. You can go online to check the documentation about the Grand Central Dispatch. Okay, and we're gonna refer that as GCD sometimes. Okay, just an acronym. Now, why we want to use the Grand Central Dispatch? If you guys are already familiar with Python, C++, okay, or you can always have the freedom to create your own thread, create your own process, okay, freely, okay, and manage these threads, in whatever way you want, okay. So why we want something fancier, like Grand Central Dispatch, okay? So the reason is, first, the Grand Central Dispatch as a kind of manager, okay, to control all the threads, managing all the tasks, okay? It can manage the threads for you, and in which case it may improve performance by reusing free threads instead of just creating threads, destroy threads, creating threads repeatedly, okay? So how many of you are familiar with the thread pool, the concept of thread pool? Would you like give some brief introduction about what kind of thing thread pool is?
Sure. So in the case of Grand Central Dispatch, we might create, or at some point in the process, we might have 20 threads that the process has, and then maybe we're only using 12 to do downloads and UI and some other things. So 8 are available; they're still existing but unused. So then, if you create a new task on another queue, Grand Central Dispatch can just use one of those threads without having to create another thread.
Yes, exactly. So thread pool is, as the name suggests, is a pool of threads. Okay, so it kind of create multiple threads for you at the very beginning and keep all these threads alive. Okay. The reason why thread pool can actually improve your performance because it avoids the kind of repeated process of creating and destroying threads, which can be really costly. Okay. And another reason why we want to use Grand Central Dispatch is it can help you to utilize all the cores in your CPU more efficiently and elegantly. Okay. Otherwise, you have to manually check and use all the free CPUs and spawn maybe new process or threads. Okay, manually. Okay, because you have in modern technology, you have lots of cores in your CPUs. Okay, and usually you want to utilize this full potential. Okay, and when it comes to using some low-level API, it gets really complicated. So Grand Central Dispatch manages all this complexity for you. So it abstracts all the complexity away. Okay, and the next thing is it also utilizes all different types of CPUs cores. Okay. Because, maybe, in iPhone or in modern phone architecture, CPU architecture, they have different types of CPUs. Okay, some CPUs can be more efficiently. Okay, and some CPU have more performance to perform more complicated tasks. Okay. And the Grand Central Dispatch, again, abstract all this thing out. So you can just simply use Grand Central Dispatch, and you can actually dispatch these tasks to different type of CPUs according to different context. Okay. Now, well, there are actually lots of more other reasons why you want to use Grand Central Dispatch, but we're gonna stop right here. And now, when it comes to Grand Central Dispatch, there are two major concepts. Okay. So first one is thread. Okay, you guys already seen the kind of illustration of thread last time when we talked about the web API, like why we need threads, like why we need async await in the, like when we initiating the web API request, right? And another concept we gonna learn is something called dispatch queue. Okay, so Grand Central Dispatch is kind of a name referring to the entire system. Okay. And comes with threads and dispatch queues. Okay, so we will get to that one by one. Okay, so first threads. So again, let's assume we have some main thread, which we already went over last time. So every app at the very beginning of its life cycle, the system creates some sort of main thread for the app. And all your code actually running in the main thread, okay? Otherwise, except you kind of explicit about like, I want to dispatch some task to other threads, okay? So we got a main thread. Of course, during the lifetime of your app, you may want to create multiple other threads. So for example, you can have a new thread for initiating web request, okay? And of course, you may have some other threads for like accessing database, writing to the database, all kind of thing. Lots of other threads you may want to create, okay, throughout the lifetime of your app. Now, let's take a look at the concept of dispatch queue. Okay, so dispatch queue, as the name suggested, it's a queue. Okay, and this is a queue where you actually gonna submit different tasks. Okay, and task in this context actually is some sort of function or closure in Swift. So you submit a sort of function into this dispatch queue. Okay, is that clear so far? So you can see right now we have like 3 tasks here. So task number 1, task number 2, and task number 3. Okay, so for example, maybe we can have task number 1 as just some, print statement here. Okay, so this is our task, and we can submit, okay, the task to this dispatch queue. Okay, so for example, we can do things one by one to submit all the 3 tasks into one dispatch queue. Okay, this is just one dispatch queue. Okay. Now, later, so we submit all these tasks into dispatch queue, but I mean, it's just a queue. Okay, your code still has to be executed, like sometime, right? These tasks in the dispatch queue will be popped out, okay, and actually get executed in some thread later. And this behavior, when you how to like pop out things or adding things into this dispatch queue happens in a FIFO order. So first in, first out, okay? And this is actually quite important in dispatch queue. Every behavior, like whenever you're adding or removing things from dispatch queue, it always happens in FIFO order. There's no exception, okay? Now, let's take a look at how we actually use the dispatch queue to like utilize the dispatch queue and how the dispatch queue actually internally managing all the threads for you. Okay, so for example, we already have submitted like 3 tasks before, like into this dispatch queue. Okay, and now dispatch queue gonna actually trying to execute all these tasks. Okay, so first thing you're gonna do is gonna pick up some threads if there are some threads available in the system. Otherwise, you're gonna create a new threads, okay, for you. Okay, so you don't need to create the threads explicitly. Okay, all this thing done implicitly behind the thing. Okay, so first, in this case, you're gonna pop out the first one, the task number 1, okay? And to put that into some threads, and this thread is gonna execute all these functions, okay? Which is, in this case, it's just task number 1, okay? And of course, when the task 1 actually get done, the dispatch queue gonna pop out the second task, okay? And second task gonna be put onto, well, some other threads. Well, it can be the same threads, it can be some other threads. Okay, depends on this dispatch queue to manage the behavior for you. Okay, so you don't have that transparency. Okay. Of course, well, you can also the dispatch queue gonna also trying to execute the task 3. Okay. Is that clear so far? So how internally the dispatch queue how the dispatch queue manage internally the threads to get your job done. All right, is that clear so far? Okay. Now, so let's talk about like 2 different types of dispatch queues. Okay. So when it comes to dispatch queues, we have 2 different types. First one is serial queue, and the second one is called concurrent queue. Okay. Now first, that's actually that's the important note I mentioned before. So all the things inside dispatch queue happens like dispatch queue always dispatch tasks strictly in the FIFO order. Okay, you're gonna see that later. Okay, when it comes to priority, how to prioritize different tasks. Okay. Now first, let's take a look at the serial queue. So you actually already see that example in the previous slides. So in the previous slides of like showing you how the interaction between the dispatch queue and the threads is kind of sort of behavior of serial queue. Okay. So right now, assume we have something called serial dispatch queue, and it's just one queue. One dispatch queue, okay? And it has 4 tasks and maybe more in that dispatch queue, okay? And this serial dispatch queue gonna serialize all the process and pop out one task at one time, okay? For example, right now you're gonna just pop out the first task and put that into maybe thread 1, okay? For example, like assume we have right now in the system we have 3 threads available for us to execute tasks, okay? Now, when the thread 1, when the tasks on the thread 1 finished, okay, you're gonna pop out the second task, okay, and put into one of the threads, okay. Maybe in this case, maybe you're gonna put this task to thread 1 to execute this task, okay. Now, after this done, well, maybe sometimes you decide to go with different threads. It happens, okay? So you cannot assume all these tasks in the dispatch queue gonna happen in the thin thread, okay? It's not guaranteed, okay? It can happen in different threads, okay? Now, when the task 3 get done, well, you can pop out the last one and put maybe one of these threads. Okay, is that clear? All right, so just review and summary. So serial queue can only dispatch and perform one task at one time, okay, until that task actually returns. Well, in this case, I mean actually the function or closure returns. Okay, now it can. When that task returns, when that task finished, you can move on to the next one. Okay, so only one task at one time. Okay, is that clear? How the serial queue perform? Yeah. Okay. Now, let's take a look at the concurrent queue. So concurrent queue, as the name suggested. Right now, you're trying to do things concurrently, okay? For example, again, we have like 3 threads available in our system right now. And then Grand Central Dispatch this kind of system, okay, already know you have 3 threads available, okay? Now, you can actually just pop 3 tasks out, okay, and assign all these 3 tasks to 3 threads, okay, at one time. But of course, you have to keep in mind, all these things happens in the FIFO order, okay? So first, the task 1 gets out first, and then task 2, and then task 3, okay? So now, you have 3 threads are executing 3 tasks concurrently, okay? This is how concurrent queue behaves. Again, some summary. So, sorry, it should be concurrent dispatch queue. So, it's a typo. Concurrent dispatch queue can dispatch and perform multiple tasks at a time, okay? Now, let's take a look at how we actually, well, use the code. So right now, by far, you already know the concepts of like the interaction between dispatch queue and threads. So how are we supposed to create our own dispatch queue, okay? And to submit the tasks to the dispatch queue. So first thing we're gonna say is something called dispatch queue, which is a class, okay? And it has initializer, which requires 1 argument. It's just a label. It's some sort of name for that dispatch queue, okay? And well, by default, when you just apply a label argument to the initializer, by default, it's gonna be a serial queue, okay? Just like the example above. And you can also be explicit to say this one should be a concurrent queue, okay? And you have to use another argument, says attributes, okay, and pass a concurrent into that one. So now you get a concurrent queue. Okay, is that syntax clear? All right. Now let's focus on this serial queue and see how we actually can submit different tasks to that queue. Okay. Now you can see right now, there are 2 different options. First one called sync, the queue, like serial queue.sync, okay? And next one called serial queue.async, okay? We'll get to this difference in the next slide. But from the syntax level, is that clear for you guys how to submit the tasks? So you can say like serial queue.sync, and in the argument you pass into the sync function is actually a closure, okay? It's some sort of task you want the dispatch queue to execute, okay? Now, let's take a look at the difference between .think and .async, okay? So, let me give you guys some definition. So, the .sync function will block the current thread, okay? And keep executing the following codes only when the submit task is finished. Otherwise, the current thread just gonna remain blocked. Okay? Is that clear how, like, what I mean by blocking the thread? Is that clear, the concept? Okay. Now, let's talk about the async. So async will not block the current thread. Okay? Instead, it's just gonna submit the task and immediately returns. Okay? So the task's gonna still be executed sometime in the future. Okay, because it's already in the dispatch queue, and it will be sometime at some point in the future, it's gonna be popped out from the dispatch queue and put the task into some thread and to be executed. Okay. The major difference between these 2 is one gonna return immediately and one gonna wait until the task is finished. Okay, is that clear? The difference between these 2. Now, actually, take a look at an example here. Let me see. So, I have a playground file here. I will push this file to our course repository after this class, okay? So first, let's take a look at this thing. So I define a function called run serial queue. Okay, and inside the run serial queue function, wait, is that visible to you guys? Give me a second. Is that better? All right. So inside this run serial queue, again, I define another function called run sync call. Okay, and let's take a look at the implementation of run sync call. Okay, so it takes a dispatch queue. Okay, and it just simply loop through from 0 to 4 like 5 times. Okay, and you're gonna actually submit 5 different tasks. Okay, and before you actually submit the task, you're gonna print something. Let's say ready to submit sync task. Okay, and after the submission, you're gonna say submitted sync task with the number. Okay, and inside this task, so first we're gonna say, okay, we got started. Then we're gonna sleep like 2 seconds. This is a function called say sleep. Okay, you essentially sleep the threads for like 2 seconds. Okay, now after all these things finished, you're gonna say finish sync task with the number. Okay, is that clear so far? All right. Okay. Now let's go back to this run serial queue. Okay, so first thing is of course I'm gonna create a serial queue. Okay, in this syntax, I'm gonna submit 5 tasks. Okay, in a synced way, where we call the .sync. Okay, on that serial queue. And let's take a look at what kind of behavior it has. Okay. So let's run the main function. Inside that, we run the run serial queue function. Okay. Well, you can see different, like all these 5 tasks get submitted like sequentially, right? So, well, so is that clear why the ordering happens in this case? All right, good. So you can see that first you're gonna say ready to submit, okay? And you're actually gonna start and finish the task, and well, I say already submitted, okay? Now, let's take a look at another function. In this case, we have a function called run async call, okay? This one is actually, well, essentially quite similar to the previous one. But the only difference here is, in this case, we're going to use .async. Okay? Use .async to submit the tasks. So again, quick question. So what's the difference between async and sync function call? What's the key difference? Anyone? Yep.
Async is not blocking.
Yeah, async is not blocking. So what happened when we actually use the async to submit a task? You can just quickly submit all these 5 tasks. All right? Now let's take a look at the behavior here. So let's comment out this one and run the async call. Okay. Let's run the main function here. Okay. Now, well, you can see at the very beginning, you kind of submit all these like 5 tasks like immediately, okay? And now all these 5 tasks get finished one by one, okay? So have you guys seen the difference between the async and sync? How these things behaves? Right? Well, any question on that? Okay. Now, let's move on to the next thing. Give me a second. Let's see. Oh, wait a second. Okay, so actually let me show you the sync call one more time. Okay, so since the sync, when you submit the task with the sync is blocking method, okay? So you can only, let me actually go about, so for example, in the first loop, okay, you're gonna submit this task, okay, but the thing is, it's blocking because it's using the sync, right? And when using the sync, all the current thread is blocked until this task, okay, included in this closure form, is finished, okay? So that's why your for loop is kind of blocked until the first one is actually finished. Then you can kickstart, like, you can start the second one, okay? Now, let's take a look at what kind of behavior the Grand Central the dispatch queue gonna have when you actually block a thread, okay? So for example, right now you have, let's assume we have a concurrent dispatch queue, okay, and we have several different tasks right here, okay, and all the the first 3 tasks are submitted with the sync call, okay. By doing that, for example, right now we're gonna pop out the first task, okay, actually first 2 tasks, and put them to the current 2 available threads. Okay, we're trying to execute these 2 tasks on 2 different threads. However, the thing is, they are sync function call. Okay, so all these threads gonna be blocked. Let's assume both task 1 and task 2 gonna take quite a long time to finish. Okay, so right now both threads are blocked. The thing is, let's assume right now in the system, we only have 2 threads available. Okay, now what if we want to still continue to execute the third task? Okay, so the Grand Central Dispatch is gonna, again, manage the thread for you. So you're gonna actually create a new thread. Okay, you're gonna create a thread for you. So you don't have to manually to create threads again. Okay, now you're gonna put that sync function into the thread 3. Okay, is that clear how internally the Grand Central Dispatch manage the threads for you, right? Okay, there is a tiny problem or tiny caveat I think I need to mention here. So when you use a lot of sync function here, and you actually block lots of threads, actually you're gonna encounter one major problem. It's called thread exploding. Are you guys familiar with that concept? Just a fancy name. So essentially, you're blocking 2 main threads. So what kind of behavior the Grand Central Dispatch gonna do? Okay, it's gonna create create a new thread for you. Okay, but if you're blocking 2 main threads, you're gonna create lots of threads. So right now in the thread pool, you have 2 main threads to manage, and also you're gonna do context switch a lot. And the context switch, how many of you haven't took the ECS 150? So are you familiar with the context switch, the concept? Okay, so essentially, for example, assume we have different process, okay, and we can have different threads in one process. And right now, maybe you want to switch from one process to another process, and the system gonna save some context, okay, and later when the CPU switch back to that process or that thread, you're gonna kind of retrieve that data back, okay, and restore that state. In that sense, you're gonna actually have some overhead, okay? You have some extra thing to do when you switch between different process and different threads, which is called context switch, okay? And I mentioned before, and just as I mentioned, the context switch has an overhead. So when you're creating lots of threads, the context switch, the cost of context switch can be really a huge deal, okay? And at that time, you may notice, even you have lots of different threads, you have like thousands of threads in your system, but the efficiency actually drops, okay? the performance actually drops because now your CPU actually put lots of time to do the context switch instead of actually doing some useful things. Okay, and this is called threading explosion. Okay, so thread pool actually explode. All right, just some fancy name. Okay, now let's take a look at how we actually can prioritize different tasks. Because in the real world scenario, you may want to, well, you may have different tasks, right? And different tasks with different priority. You may want to prioritize some tasks, maybe you may prioritize some UI updates, okay? Because you want your app to be responsive, okay? So how we do that? Now let's introduce something called quality of service. And quality of service is, well, it's a struct defined in the core foundation standard lab. Sorry, it's not, maybe it's not core foundation, but it's defined in standard library, okay? It just have some static let variable, okay? And it represents different, well, priority. So let's take a look at this thing, okay? So the quality of service, usually we call as QoS, okay? It kind of represents the execution priority in the dispatch queue, okay? And it applies to tasks. And I already copy paste this URL here. You can go to the official documentation to see full document, okay? But usually we have, so for the quality of service, usually we have this maybe 5 predefined quality of service in the standard library. First one is called user interactive. And then next is user initiate. Then it's default one. When you just say .async or .sync, usually go with default one, okay? And also you have something called utility, which is kind of low priority, and the background is gonna be the again, the lower priority one, okay? So from top to bottom, the priority decrease. Okay, is that clear? So now how we actually can use this, something called this QoS, okay, to mark our tasks with different priority. Let's take a look at the code. Again, let's assume we have some serial queue, okay? The syntax looks like that. Now, usually we want to, well, as you've seen before, we can submit tasks with .async, right? And in that function call, just say, well, print something, right? Now, I can also put an argument into this async call, okay? And the argument, the labeling, the external name is called QoS, okay? And you can say .background or .user interactive or .user initiate, or maybe just .default, .background, .utility, okay? To specify the priority of the task you're gonna submit. Okay, is that clear how we use this thing? All right, now again, let's take a look at an example here. So here we go. So here we have a function called submit QoS tasks, okay? And just as I showed before in the slides, okay, we have different function call in this case, okay? And well, first one is kind of the default priority, because we just use the default arguments, okay? And second one is gonna be a background. It's kind of lower priority than the default one, okay? And the third task we're gonna submit has a user interactive quality of service. And this one is actually has a higher priority than the previous two, okay? It's higher priority than default and higher priority than the background, okay? So now let's take a look at the behavior. So we call the submit QoS task here, okay? Maybe actually before we running this code, any guess like how this gonna behave? What kind of, yeah?
I guess it's, pre is gonna run first, and then probably async, and then background.
You're gonna, so which one runs first?
User interactive.
User interactive? Okay. Good guess, but let's take a look at this thing, okay? So let's run the main thread. Wow, it takes 2 seconds to finish the first one. It takes 2 seconds to finish the second one. Again, it takes 2 seconds to finish the last one. But you can see, well, even though we see the QoS, the third task with a kind of higher priority, but it still get executed kind of in the original order. Okay, so again, this is big caveat in the Grand Central dispatch. Okay. Now, so why? Let's try to understand why the user interactive with the higher priority actually happens after the default and background priority. Okay, so the QoS won't help you to rearrange the tasks that already been submitted to the dispatch queue. Okay, so the QoS can only help you to make sure the higher priority task can be executed as soon as possible, but it's just as soon as possible. Okay, so again, still remember the one important thing I mentioned before is all the tasks in a dispatch queue can only be dispatched in the FIFO order. Okay, so there's no rearrangement happening behind the thing. Okay, when you submit the task later than the first one, it will only be executed later than the first one. Okay, so let's take a look at the illustration of different things. So again, well, you can see right now we have 2 tasks, okay, and the color actually represents different priority, and brighter green stands for a higher priority. In this case, first we're gonna submit the first task, which with a default priority, okay, and it has a little bit brighter green, okay, and second task has a background priority, okay. Now, what if we have a third task just got submit to the dispatch queue, okay, with a much higher priority. In this case, it's going to be user initiated, okay. As I mentioned before, well, this is something called priority inversion, okay, just some terminology, fancy name for this kind of specific situation, okay. So when the higher priority happens after some lower priority task, we call this as priority inversion, okay. Now you may, well, we have actually discussed about that, so we may guess the dispatch queue gonna rearrange different tasks because, well, we have something with higher priority, okay. But the thing is, again, no, dispatch queue won't rearrange the tasks in the queue, okay. Instead, again, go back to the previous situation. So we have 3 tasks. Okay. Now, behind the thing, actually, when the dispatch queue detect this the priority inversion, it's gonna bumps up all the priority before the task 3. In this case, it's gonna bump up the priority of first 2 tasks. Okay. Right now, the task 1 and task 2 actually behind the scene have a priority with user initiated. Okay, it's kind of equal priority with the third task. Right now, it's just kind of still, well, it still happens in the FIFO order. Okay, execute things one by one. Okay, is that clear? Now, well, actually, let me go back to the code. So right now we have a serial queue, okay? So what if we actually trying to use a concurrent queue with attributes as concurrent? So give a guess about the behavior. Any idea how I'm gonna behave this one? So we just switch from the serial queue to concurrent queue, sorry. So actually, you're gonna see the third one gonna execute first, okay? It's a little bit odd, but you can see. So you can see first go with the default one, and now you can start to the user interactive and now the background. Okay, so it's kind of counterintuitive, right? Well, compared to what I've said before. So the thing is, indeed, for a concurrent view, you can pop out different texts, okay, and schedule them to different threads. Okay, that's the truth. And also, this thing only happens in the FIFO order. This is also the truth. The thing is, the concurrent queue can actually to activate certain threads, okay, earlier than other threads. So when you submit all these tasks, all these things still, again, happens in the FIFO order, and you still need to bump up all the priority of all the other tasks before that third task, okay? But right now, you kind of activate the third threads more earlier than other two threads, okay? Is that clear why this kind of counterintuitive thing happened right here? Okay. Now let's go. Let's switch back to the serial queue. Here we go. Oops. Now, let's go to the next topic, synchronization. Okay. So we're just gonna briefly discuss the synchronization. And in this case, I'm gonna show you guys a scenario where we can utilize the dispatch queue to achieve a lock-free synchronization. Okay. So take a look at this class, something silly name called as shared data, and it has a local variable called shared data, or shared, which is an integer in this case. And for example, we have defined two functions. One is called set shared value, and the second one is just simply reading the value. Okay, is that clear? Now, so what's the problem of this class when it comes to the multi-threading or concurrency world? Any idea? Come on. Yeah, data arrays. Which one? Well, yes, it only has one field. So yeah, potential data arrays. Because when you initiate multiple threads, to access that field called shared, so it can happens maybe sometimes you set the shared value, okay? But when you actually assign this value to this local variable, maybe other threads gonna say, I'm gonna read the value. But right now, the value you just read in is not really the value, just get updated, because well, the update haven't been done, right? Okay. So this is potential data risk. Okay. So any solution on that? What kind of solution you can think about? What kind of techniques you're gonna use? What kind of tool? Come on. Yeah, Latif.
Dispatch queue and maybe the sync.
Exactly. So so first get rid of the dispatch queue. So without dispatch queue, have you? Come on. Locking mechanism, right? You can think about like how to use a lock, right? Actually, there's a lock. Actually, there are lots of locks. So going back to the old world, when we use Objective-C, we can directly access the C lock. Okay, so which is a lock defined in the C language. Okay, it's called pthread mutex lock. I forgot the exact name, but you can access that lock. But that lock is primitive. Okay, so in modern days, the core foundation provides another type of lock, okay? And it's called, well, it's just called lock, I believe. It's defined in the foundation library. Okay, just called lock. You can search online and to take a look at the documentation of that one. Of course, you can use lock, okay? But using lock have some problem. So for example, well, you can sometimes forget to release the lock, okay? And you're gonna resolve. You can have kind of like deadlock situation, okay? Now, as well, Latif mentioned, we can try to utilize the serial queue with the sync function to achieve a lock-free synchronization in this case. Okay, so to take a look at the new code. So what changed? So we have a queue. Okay, in this case, it's a serial queue. Okay, and when we actually set the value or read the value, we put these tasks into that serial queue with a sync function. Okay? Is that clear? The syntax or, okay? So does that make sense, like why this one can prevent the data erase? Okay, and actually in this case, we are not using lock. So you won't actually forget to release the lock. The deadlock, well, the deadlock still can happen in this case. Not this case. Well, when it comes to a more complex scenario, it can still happen. But for this simple use case, right now you kind of avoid the deadlock. Okay, you avoid releasing the lock manually. Okay, is that clear? Okay. Now, let's talk about some special dispatch queues. Okay, Grand Central Dispatch as a threading managed system. Okay, manage lots of queues for you. Okay, manage lots of dispatch queues for you. So we have introduced customized queues. Okay, so far we have been creating lots of different customized queues. Okay, like concurrent queue, serial queue. Okay, like to customize the concurrency behavior. Okay. However, there are actually some special dispatch queue already created by the Grand Central Dispatch at the very beginning of your apps or even the entire system. Okay, there are two major special dispatch queues. First one is called min queue. Okay, min queue is a serial queue. Okay, and all tasks on the min queue will be executed on the min thread. Okay, you will not use other threads. Okay, you will only use the min threads. In this case, you may want to sometimes use the min queue to do some UI-related work. Okay, just as how we use with the min actor before. But we will get to the min actor maybe next lecture. And the next one is called global queue. Okay, global queue is a concurrent queue, and this queue is shared by the entire system, by all different apps in your system. Okay, let's take a look at some simple usage of these two special queues. So the min queue, you can access that by directly say dispatch queue.min. Okay, again, this is a queue defined for you. You can say .sync or .async to submit task to that queue. Okay, and all this tasks gonna be executed in the min thread. And for the global queue, you have actually lots of function here. There's one example. You can just say dispatch queue, okay? And by using this, you are referring to the global queue, okay? You can see something like concurrent perform, essentially concurrently perform multiple different tasks, okay? Multiple iterations, okay? The signature looks something like that. You can go online and check this out, okay? Well, and of course, we have lots of other functions and concepts in the Grand Central Dispatch. It's really complicated and powerful tool for you to manage all these concurrency things. Okay, so if you are interested, you can take a look at the function like async apt, which allows you to asynchronously execute some task after a certain period of time. Okay, and you can also use schedule, which comes with the combined framework. Okay. And lots more. And also, you may want to take a look at this something called dispatch work item and dispatch group. Okay, just some advanced concepts here. And that's all for today. All right, thank you guys.